So table partition. So partition the HANA tables here. So why we have to do the partition? So some tables, some finance tables, some ledger tables, they have more entries, more finance will happen. So more entries will store in the database table here, right? Database table here we have to, using this partition, we can split column store table into the smaller table in the multiple host or same host in the partitions. We can split the tables into the smaller here. So using the partition concept here, right? So we have the large table that we can split the entries here. We can divide the entries into the partitions wise, right? So partitions wise we can split it out here. So in this way, so if in this way the performance will be improved. The pulling the data from the, suppose you have the more records are there, suppose the example, this is the one of the table here, right? In this table we have the 4 billion records are there here, right? So then pulling the data from the this table, all the records, it will set it out, it's very huge table, right? Is a very huge table. So 4 billion records means there's a huge table here. There are a lot of data is there here. So it will take some time to pull the data from the in this table here. Suppose if you have splitted this table into the two smaller chunks, right? The smaller wise are equally, if you split it, what will happen? This table will split into the smaller table here. Then so getting the entries from the two smaller tables is so very easy, right? Some threads are here to pull the data, some threads are here to pull the data. So easily you can grab the data here. But getting the same data in the larger table, one bucket, so it's very time taking process here, right? So there is a procedure in HANA to improve this type of performance issues, right? So we can split the column store tables into the small tables in a multi-host system, which we can divide the table into the smaller, more manageable partitions. We can partition it here. So either HANA Studio, we can do the partitioning, or we can also, other HANA Studio we can use to do the partition, or yes, SQL statements, we can use the partition here. SQL statements means we have to write a query and execute. Otherwise, we have to use the HANA Studio, the best approach to do the partition of the systems here. Partition of the systems here. The partitions of the systems, we can use it here. So as per SAP recommendations, if any table, if any table more than 2 billion records, billion records, if any records more than 2 billion records, then we can go for the partition. If any table has more than 2 billion records, we can go for the partitions in the HANA database, so that it will improve the merge operations, parallel processing of queries here, right? During the Melda merge, if the data is only modified for the sums operations, then it need take less merge partition to the table here, and parallel processing of the queries here. So there is a multiple smaller tables are there. The parallel processing happens to the smaller tables here. So right. So there the partitions are there here. Partitions are there here. Partitions are there. We can use that partitions here. Right. That is the partition. So there is a lot of improvements to doing the partition here. Right. So size and improve the delta merge and load balancing purpose here. We can divide the individual partitions into the multi-host systems here, so that so better wherever we have the data, immediately that will fetch the data from the systems, and so that will be easy to fetch the data from the systems here, right? So partitions we can do it from the multiple ways here. Partitions we have there are the three types of in a single level partition. They are the single level partition. So they are the different types of single level partition available in the SAP here. Single level means the first time we are partitioning, that is single level partitioning here. The one partition.
Ravi, one point. I mean, so how we will get that in the table? How many records are there?
Yes, I'm coming to that point. Give me Radhika sometime.
Okay.
Otherwise, yeah, it will be disturb the class flow and everything. Okay, I am coming to that part. So here the hash partitioning we can do it here, right? Then So round robin method here. So round RO you so round robin partitioning, and the third one is the range partitioning here, range partition here, right? So range, so partition here, so range partitioning we can do it here, right? So range, so there are the three types of partitioning available in the, so in the single level partitioning here, right? So here, so first of all is the hash partitioning or round robin part. These are the methods here. The ways we can do, either SQL statement we can use it, or HANA Studio we can use it here. SQL statement means, so there is a difficult to find out the SQL statement. Maybe if you in the help document we will get the SQL statements. We need to compile that statements, cause that syntax, and we can do. But HANA Studio, it's a easy to perform the statement here. But if any table, so we have to go for the partition. If any table has more than 2 billion records only, then how can I get this one? Each table, how many entries are anything? So HANA every time will report if any table has more than records, more records are there. So HANA will report in the alert section. In the alert section, HANA will report us. In the alert section, HANA will report how many entries are there in the each and every table. It will give you the information here. It will give you the information here. I am not sure what is the password for this one. So here, if you go to the alert section, always it will report like you have these tables have more records, something like that. We may get the information. Something we will get the information. If suppose ANA always as per the ANA alerts configuration, if any table record count of the non-partition table here, see, if any table more than 2 billion records here, so then that will be reported. That check will be happen, that will be reported here. You no need to do anything, that will be reported here. If any table, so the tables list we have to take it out, we have to do the partition here. Otherwise, if you want to do the manual thing here, then definitely there is a system information. Go to the SQL statements. Let's check if any table record logs, record count, any SQL statements or anything. This is a size will be displayed. Okay, so size will be displayed. So maybe query, SQL query. So record count SQL query. So then each table, how many records are there? That will be displayed here. That will be displayed here. Otherwise, we can see the size, and execute. So this is a disk size only. This is a size is different. How many records are different? No records are coming here. So this is not the correct query. So if you Google it here, select schema name, table name, disk size. So maybe record count, record underscore count slash one. No, record count is not the field. So maybe there is a different way to fetch it out. So yeah, there is a different way to, maybe definitely there is a SQL select statement. So we can pull that one from the list. How many records are there each and every table here? If you just do the help.com, you will get things here. So here based on the, otherwise in the alerts tab, always it will show the alerts notifications. So this table has this many records, this table has this many records, like that. Based on that, we can find out the list of tables. Otherwise, if you see your EWA report also, it will show the data here. So based on that, we can go to the catalog here, catalog, then system, whatever the schema. Suppose like whatever the schema you have here, based on that, we can go to that schema. So the table schema and table here, it's only for column table here. These all are the row store tables here, not the column. These all are the row store tables here, system configuration tables here. These all are the system configuration tables. So let me create the one table here. But that many records we cannot create it, but we can create the one new table here. So one new table we can create, suppose like jet finding table. So it's a column store tables, maybe name, so number, so number, some information we can create it here. So one table will be created here. So refresh, then you see the table here, right? So here in this way, what we can do here, so here in this way, if you just right click on the table here, so we can load, unload this one, we know, right? We can load, unload, we can know here. But here, select the schema, right click, select the schema and right click, show table distribution, show table distribution here, right? Table distribution here. So here, the list of tables in that schema will be displayed here. Select the table, which table you want to do the partition, which table you want to do the partition. Just select that table here, select the table and right click and do the partition table here. So first level partition, you can see here hash partitioning, round robin partition and range partition here. Hash partitioning is like a, the rows are distributed equally, the rows are distributed equally to perform the load balancing. So equally the rows will be distributed among the containers here. How many partitions are there? So the rows will be, suppose we have the 1 lakh records are there. Suppose example, in this table we have the 1 lakh records are there. So then what will happen? This we have the two partitions are there. 1 lakh records are there means then 50,000, 50,000. Like that, it will create the smaller, equally distribute the rows to the two tables like that. It will distribute the loads records here. That is called the hash partitioning here. So either you can choose the number of partitions equal to that here. Otherwise, you can choose the two rows are there means you can select the two. Then click on the edit. So select the primary key. What is the column you need to select it for the partition? Click on the OK button here. Here the partitions has been completed. Table has been partitioned here. With a small table, it will complete quickly. It's a very large table. It may take time. So hash partition is the, so rows are equally distributed the among the partitions, equally distributed equally to perform the load balancing. The rows are equally distributed here. So here we don't require detailed information about the table content and everything here. Just simply hash select containers, we can do the partition. The rows will be equally distributed here. The rows are equally distributed among the container here. You can see, so they are the two partitions here. If any total size, any records count here, if you see the two partitions here, so here two records, something like that, it will show the, so how many partitions, it will create the partitions wise, it will create the data here, it will create the partitions wise. So it will create the data here, right? So that is the, so training, that is the table here, partitions wise, it will create the table here, right? That is the one thing here, hash partitioning here. So hash partitioning means the rows are equally distributed to perform the load balancing and everything here, right? Either two or four or eight partitions we can create it here, right? That is the hash partitioning. So which means this is fine. Everybody will use the hash partitioning. Suppose if you go to the, so merge the partition back to previous status here, non-partition table. Right click and partition the table here. Then there is a partition called the round robin also here, round robin and range partitioning here. So round robin and the range partitioning here, round robin and range partitioning here. So round robin means here, so round robin and range partitions are different here. So round robin means, so here like load balancing purpose. So some rows are in this partition.
और हाथ का दर्द नस से है, नस का दर्द है पीछे जो आपका स्पाइन होता है उसमें सारा
What is this here? So range partitioning. Range partitioning ऐसे के the range partitioning is like a dedicated partitions for certain values we can create it. Range means the values based partition we have to create it here, which means which values are in the which partition, which table content. So here in-depth knowledge for the table contents are required here, right? So in-depth knowledge is table content is required here, right? So why? Because here the range values we have to provide it here. Range values we have to provide it here, right? So for the what ranges are in the start level, what ranges are in the different end level, the ranges we have to create it here. The ranges means to search in SQL query searching, okay, 1 to 110 values, 1 to 1 entry here, then so 9th 10th entries here, values here you have to check like that. So the value ranges between here one partition, then in the second partition like 11 values to, then 11 to 20 in this partition, then third partition we have to check like so 31 to, then remaining 31 to, sorry, 21 to the remaining 29 values here we can check it out, or remaining 30 values you can check it out. So like that we can do the partitioning here. So like that we can estimate the partitioning here, but size is required here. So means in-depth knowledge is required to perform the, so the range partitioning here. Some in-depth knowledge is required to perform this range partitioning here, right? The name, which values we have to change it here, number, which number we have to change it here, right? Values, number, range based upon the column, based upon the values. So we have to do the partitioning. So it's kind of a difficult partition here. Difficult partition. It is required the some in-depth knowledge of the partition is required. In-depth knowledge of the partition is required here. Means in-depth knowledge is required to perform this partition. In-depth knowledge is required here, right? So why? Because here how can we know in the partition one how many, which entries are started, which entries are excluded in the partition two? So like that the start entries and so the start entries and all those things we have to enter it here. All those things we have to enter it here, which means here the lot of things are required here. A lot of things means some in-depth knowledge is required here. In-depth knowledge is required here, right? So that is the one thing here. There is a one more partition you see here, that is called the round robin mechanism. Round robin mechanism here. Round robin partition also used to achieve the equal distribution of the load. Equal distribution of the rows. Equal distribution of the rows to the partition. Unlike same as like attribution, equal distribution of the work. But here we no need to specify the any columns and everything here. So new rows are assigned to the partitions rotational basis. Rotational basis, the rows are assigned here, right? Here we don't require to copy anything here, right? So here round robin based mechanism here. Suppose example happens, same as like hash partitioning and round robin, both are same. Both are equally distribution of the rows to the among the partitions. So but hash partition is like a, so here 4 billion records, here 2 billions, here 2 billions. So 4 billions completed. But hash partitioning also the 4 billions are there, here 2 billions, here 2 billions. Then if any one more entry is coming, it will assign the one more record to the here. Then one more entry is coming, it will assign to the one more record to the here. Means rotational basis. We don't have to specify the any columns here. Then here new rows are assigned to the partitions are rotational basis here, right? The table must not have any primary case in this case here. So the rotational basis, the round robin basis, round robin mechanism means one is assigned to this request. So round robin basis means what is round robin? So you have the three application servers are there. Their message server will assign the first request to here, second to here, third to here, then fourth to here, fifth to here, sixth to here, 7, 8, 9, like that. The round robin basis, round robin mechanism, it will assign the equally assign the distribution. Same as like round robin partitioning means same as like hash partitioning, but here we no need to select the any columns. Here we need to select the columns. Here the additional thing is here the round robin basis, the new rows are assigned to the partitions equally. That will be assigned here. That will be assigned here. That is the so round robin based. First record goes to the first to processing node, and the second record goes to the second node, so on like that. So it will go to the round robin basis. But hash partitioning is not like that. Range partitioning, value based. So more in-depth knowledge is required here. So here to get the inputs, how many records are there? So you can right click, and if you go to the information, you will get it out here. So to do the partitioning here, go to the schema, and select the schema, which schema. Then we select the schema, which schema here. Select the schema, which schema, and here, so tables, right click, and the partition, we can to partition it here. Select, right click, and so sorry, not the here, go to the schema and show the table distribution. Here we can select the schema here. We can select the schema. Let's see any schema here. Then all the schemas will be displayed. Then right click and do the partition. Do the partition here. So we can also see the content, how many records are there and everything. We can also see the content of the table and everything here in the system, right? So how many records count is there? When we select the table, the record count will be displayed here. This way we can do the partitioning here. Okay.
Ravi, see, partition means same table. It is giving another duplicate table, or it is in the same table,
Subtable, yeah, subtable is creating. Means in our home, you have purchased a 200 square feet. Then how we are partitioning? One is the master bedroom for the something, and two master bedroom, child bedroom, kitchen, all like that. How you are partitioning your house? Same as like here. So one table is there. The table, if it is the more records, there is a performance issues, nothing will happen. But if you have small records, immediately it will go and pull the data. So just we are splitting the entries to the some other table. That's it. We are getting the same table only. So but we are splitting the entries. Just we are splitting the entries into the two or three different partitions. Suppose like there is a large table. There is a large table which has the 4 billion records. Example, it has the 4 billion records are there in the system. In this table, there are the 4 billion records are there in this table. So pulling the data from this big table, very difficult. It will take performance issues. The queries also will run longer time. We may face the performance issues. Why? Because the pulling the data from in this table where the record is, where to fetch, it should fetch, then it should check, it will go in the back and it will give the results. So, but if you do the partition of this 4 billion records into the 2 plus 2, 2 billion plus 2 billion. So then 2 billions are here, 2 billions, one more table will be created. So here 2 billions are there here. Then you have the entries here, 2 billion entries, 2 billion entries are there here. Then what will happen here? What will happen here? The searching the one table, there is a last finding out the object is different. So here two threads. One thread is will check in this table and one more thread will check in the table. So it's very simple. 2 billion records, right? Small buckets. Then just pull the data, will give the response to the users. That's it. So just pulling
If
down.
user is requesting the data which is there in the table which we did the partition, then how the response will be sent back to the user, how the search will happen?
System will take care of internally, system will take care of the request. So we no need to, we are not handovering any data to user. So HANA, based upon that, the system will check how many partitions are there. Oh, two partitions. Then two threads parallelly will be assigned to the partitions. Then check in each partition, in which partition user requesting data exists, in this or in this. It will check internally. Then, okay, in this exists. Then it will give the response back to the user. Then this thread is just silent in that case. So,
Sir, what is the second level partition?
second level partition means you have partitioned Again, we have to do the partitioning. Your partition to the table is done. Again, we can do the second level additional partitioning here. Additional partitioning of the table here. You already done the partition, then second level partitioning again. One level partitioning you have already done. Then again you want to already records long back you have done it. Then again you want to do the partitioning. Then we can do the then again second level partitioning we can do it here. Second level partitioning here we can do the hash and range only here. We don't have anything for round robin. Why? Because round robin second level is not required, right? So second level partitioning. So it's a grouped basis, the selected values, rows that we can assign to the greater than, less than. So there is a lots we have to perform. We have to check actually main. But limitation is the 2 billion records. Then the hash partition is the best. Or so then round robin also we can perform it. But when you go for the range partitioning, so there's a lot of groundwork we have to do it. What is the values? Table entry, entire table entries you need to know. And table entries are assigned to while there are which value basis, what is the minimum, what is the maximum. So those things are you required here. Those things are we have to we required. So means more in-depth knowledge is required in the in that partitioning here. So second level partitioning is the multi-level partitioning here. So there is a to overcome the limitation of the hash partitioning and range, the single level partitioning, we can use the column partitioning column. So then using the multi-level partitioning, you can partition a column which is not a primary key. Means suppose when you are doing the first level partitioning, what you are doing, so hash partitioning, you are selecting a column here. But when you are doing the second level partitioning, you no need to select anything here. You no need to select anything here without any primary key column. So without anything, so we can do that one without selecting anything. We can perform this one here. Multi-partition column means second partitioning column here, right? So which is not a primary key. Those column, why? Because hash partitioning we have to do it based upon the column only, right? Primary key only. But when you are selecting the second level partitioning here, what we have to do, you no need to select the primary key, which are the non-primary key, which are non-primary key, not a primary key column, that we can do the partitioning. So that is called the multi-level partitioning. Already table is one time it is partitioned with the column is name. The second one you are partitioning with the this because of the number, because of the this non-partition non-primary key you are partitioning here. So this is the second level partitioning here. But normally the first level partition normally we do here, everybody like the first level partitioning is the best one here.
If someone asks us to do partition, so then we have to ask them for a schema name also, right? Then only we come to know the which table.
Right. If someone asks you to do the partition of the table, partitioning, if they ask us to do means they will provide the table names definitely. So if you know the table name, we can find out the schema name. If you don't know schema name, we can ask them the schema name and everything here. So we can also find out the table name here. Just right click on the table and find the table. You are not sure about the you are not sure about the what is that? The schema name here. Then you can find out. So training is available in system schema. So suppose like CS underscore, which is available under the schema, sys schema, publish schema. There are a lot of schemas are there. CS join and so PATHS. Yes, this is available under the 3 schemas here. 2 schemas, public and schema. Yeah, we can also find out if they provide it. But majority thing, if the table has more records, definitely here it will the records list will be displayed. List of tables list will be generated. Based on that, Hana is flagging as a do the partitioning. Then we can go for the partitioning.
Sir, how we'll get the list of tables which we did partitioning already?
Already partition table, maybe SQL queries we have to write it. Check if it is available already anything here, we can find out. So otherwise, so table wise we can check it out. Suppose like in this table we have done the partitioning, right? Then if you open the table, if you open the data preview here, not here, yeah, by opening the table definition. So runtime. Here in the runtime, here we can do the, you can check it out here, how many partitions you have done it here. Yeah, based on that, we can find out. Partition one partition you have done it. Based on that, we can find out. Just now we have done it, right? We got it here. But so how can I do based upon the list of, I need list. Then go frame a SQL query. Frame a SQL query, we can get the list.
Sir, for table partitioning, do we have any prerequisites? Do we need to change any parameters?
No need to change any parameters. Only one thing is here, off business hours, we have to do the partitioning. One main thing here. With the SAP table, very important table. If you do it in the during the day hours, SAP system will be crashed. Means SAP system will not respond. Why? Because you are doing the partition of this table and there the more entries are inserting here, means when you are doing the partitioning, there is a lock will happen to this table, which it will not allow any records. Then definitely SAP will not commit any transaction. So better to stop the SAP application, do the partitioning. So otherwise in a small table we can do it. Is a larger table, definitely we need to do it in the off business hours. Especially
Is
for
there any specific time required to do the partition? Means in the hours or something?
Off business hours, we have to do the partitioning. Maybe it will take couple of hours. That depends upon the data. We cannot say like this will take 4 hours. Then if you perform, it will take the 3 hours. Or you told that 4 hours, I took that 3 hours. Means it depends upon the memory, depends upon the table size, depends upon the the hardware which you are having. That depends. We cannot, no one tell exact estimation how much time it will take it. So that's why we have to do it in the first in the non-production systems, copy of your production. So then take the estimation timelines and everything. Why? Because if you do the production refresh, then you will get the similar record, similar data. Then do the partitioning, you will get the estimation timelines. Then same, you can propose the same timelines, you can propose to the customer. Simple. The project by project, customer to customer, and so hardware to hardware, system to system, there are the very differences to do the partitioning. Also,